Hi folks, this is College Algebra Checkpoint Quiz 5.1. In number 1 we're given two functions f and g, and in part A we're asked to find the domain of the composite function f of g, and then find and simplify a formula for f of g of x. And so these two things are connected to each other. The way we go about doing this is we'll start with finding the formula. And once we find the formula, we're going to look at the step before we did any simplification to find the domain. So what does this composite function mean? This means f of g of x. So if I work from the inside out and I substitute for g of x is this entire expression. So how do I find f of this entire expression? I go back to my formula f of x. F of x is the square root of x minus 2. So I'm going to substitute for x this entire expression. So I get the square root of x squared over x squared minus 1 minus 2. So this is going to be the step we'll come back to when we find the domain. But let's go ahead and simplify the expression. So I can get a common denominator there underneath the radical. I can think of this 2 as a 2 over 1. So the common denominator is going to be x squared minus 1. So the first term already has that common denominator. What do I need to multiply 1 by to get the common denominator? Well, x squared minus 1, which means I got to multiply the numerator by x squared minus 1. So f composed with g of x equals the square root of, I've got x squared over x squared minus 1 minus 2x squared minus 2 over x squared minus 1. Now that I have the same denominator, I can go ahead and subtract the numerators. So I have x squared minus this entire numerator, so we need parentheses there. So I get the square root of x squared minus 2x squared plus 2. That's going to give me the square root of 2 minus x squared over x squared minus 1. And so that's our final answer, because there's no more simplification I can do on that. The formula for f of g of x is the square root of 2 minus x squared divided by x squared minus 1. So that's finding the formula. We're going to come back to this step to find the domain. Okay, so to find the domain, I look at this step here. This is before we did any simplification. And I look for two things. The first thing I look for domain is, do I have any denominators? Sure enough I do. I've got a denominator right there. So how do I handle that? Well, I set the denominator equal to 0, and I get x equals plus or minus 1. So as far as the domain is concerned, x can't be plus or minus 1. What's the second thing I look for? I look for even radicals, or even indexed radicals, like square roots, fourth roots, sixth roots, etc. Well, I've got a square root right there, and in order for this square root to be a real number, I need the radicand, what's underneath it, to be bigger than or equal to 0. So I take the whole thing and set it bigger than or equal to 0. I'm going to need a sign diagram to solve this. So this is something straight out of section 4.3. Now the first step in solving this would be get a common denominator. And in fact, we already did that when we simplified the formula. So I'd use the same steps as before, and I would get 2 minus x squared over x squared minus 1 bigger than or equal to 0. And I'm going to call this my function. I'm going to call it r of x, because f and g are already taken, so I'll call that thing r of x. I'm going to make a sign diagram. Okay, so how do I make a sign diagram for that function? It's a rational function, so I look for the domain first, see where the function doesn't exist, and look, I've got that x squared minus 1 again in the denominator. So on my sign diagram, two of my critical values are going to be plus or minus 1. Okay, now I look for the zeros of the function. So I set r of x equal to 0. Multiply both sides by x squared minus 1. Since I have an equation, I can get away with that. I get 2 minus x squared is 0. X equals plus or minus square root 2. So my r of x is 2 minus x squared over x squared minus 1. I'm going to make myself a sign diagram. So I've got plus or minus 1 and plus or minus square root 2. Now plus or minus 1, the function's not defined, so I put question marks there. And at plus or minus square root 2, that's where the function's equal to 0. Pick a number less than negative square root 2. Well, square root 2 is roughly 1.4 something. So negative square root 2, I could pick, say, negative 2 over there. That's a tighter squeeze, something between negative 1 and negative square root 2, say negative 1.25. Something between negative 1 and 1, 0 will work. Something between 1 and square root 2, 1.25. Something bigger than square root 2, say 2. Alright, so 1.25, negative 1.25, it all depends on if you like fractions or decimals. I'll put both of them there. So let's substitute these in. Let's look at r of negative 2. A negative 2 in here squares to become a 4. 2 minus 4 is negative 2. So in the numerator I get a negative. I plug negative 2 down here, square it, subtract 1, I get a positive. So the result there is a negative. Let's look at r of negative 5/4. Plug a negative 5/4 into x and square it, I get a positive 25/16. So I get 2 minus 25/16. I can think of 2 as being 2 over 1, so that's 32/16 minus 25/16. So I'm going to get a positive on top. If I plug negative 5/4 into the denominator and square it, I get 25/16, which is bigger than 1. That's positive as well. So I get a positive in there. R of 0. Plug 0 in the numerator, I get a positive. Plug 0 in the denominator, I get a negative. So that's going to give me a negative. If we plug 5/4 into the function, we're going to be squaring it again. Now 5/4 squared is the same as negative 5/4 squared, which I'm going to get the same thing. In fact, r of x is what we call an even function. So if you remember back to chapter 1, whatever happens at negative 5/4 is going to be the same thing that happens at 5/4. So if I plug 5/4 in, I'll get the same thing I got at negative 5/4, which will be a positive number. And if I plug 2 in, I'll get the same thing I got at negative 2, so I'll get a negative number. So what was all this about? We were trying to find the domain of that composite function, and I needed this thing to be bigger than or equal to 0. So what's the answer going to be? Well, where is it bigger than 0? Between negative radical 2 and negative 1. and between 1 and radical 2. I'm going to include the negative radical 2 and radical 2 because it's actually equal to 0 there. But I'm going to exclude the negative 1 and the 1 because the function's not defined there. And if you go back to the first step, we couldn't include negative 1 and 1 anyway, so there's no great loss. My final answer is including negative square root 2 up to negative 1, union 1 to square root 2, including square root 2. And so that'll do it for part A.